everyone, good day. This is Group 5, the activity number 6. We have the title Making Math Meaningful in Geometric Design, and also we have the theme The Importance of Understanding the Geometric Design. In our objectives, able to identify their probability and normal distribution, able to understand the linear regression and correlation, able to understand the different levels and concepts around geometric thinking. There are numerous ways to set up designs in the arts. Essentially, mathematical figures can be the result of formation and transformations. Geometric design is fully appreciated when certain figures and shape are arranged in any way to find the best angle of the form. The more you experiment with different angles, the more you will be able to create a distinct, unique position of the shapes and figures, resulting in transformations. So in this activity, we will talk 3 topics, which is probabilities and normal distribution, linear regression and correlation, and last is theory of geometric thinking. So now, let's proceed.
The normal distribution, also called the Z distribution, is a special normal distribution where the mean is 0 and the standard deviation is 1. Any normal distribution can be standardized by converting its value into z-scores. Z-scores tell you how many standard deviation from the mean each value lies. Converting a normal distribution into a z-distribution allows you to calculate the probability of certain values occurring and to compare different data sets. All normal distributions, like standard normal distribution, are unimodal and symmetrically distributed with a bell-shaped curve. However, a normal distribution can take any values as mean and standard deviation. In the standard normal distribution, the mean and the standard deviation are always fixed. Every normal distribution is a version of the standard normal distribution that's been stretched or squeezed and moved horizontally right or left. The mean determines where the curve is centered. Increasing the mean moves the curve right, while decreasing it moves the curve left. The standard deviation stretches or squeezes the curve. A small standard deviation results in a narrow curve, while a large standard deviation leads to a wide curve. So, what are the properties of the normal distribution? Normal distribution have key characteristics that are easy to spot in graph. The mean, median, and mode are exactly the same. The distribution is symmetric about the mean. Half the values fall below the mean and half above the mean. The distribution can be described by 2 values, the mean and the standard deviation.
What is probability in the normal curve? The function gives the probability that an event will fall between any 2 real number limits as the curve approaches 0 on either side of the mean. Area underneath the normal curve is always equal to 1. The height of the population is the one of the example of normal distribution. Most of people in a specific population are of average height. The number of people taller is shorter than the average height people is almost equal. And a very small number of people are either extremely tall or extremely short. Discrete probability function. Discrete events are those with a finite number of outcomes. Example, when we flip a coin, there are only 2 possible outcomes, heads or tails. When we roll a 6-sided die, we can only obtain one of the 6 possible outcomes, 1, 2, 3, 4, 5, or 6. Continuous probability distribution. A continuous distribution has a range of values that are infinite and therefore uncountable. For example, time is infinite. You could count from 0 second to a billion seconds, a trillion seconds, and so on forever.
What is correlation? Correlation relationship between variables or degree of association between 2 variables. For examples, how strong is the correlation value from -1 to 1? A1 is strongest positive correlation. Think of it, direction, proportionality. If you pay $2 for every apple, you pick correlation coefficient between the number apples you pick. And your apple picking earning is for that day will be 1. Another one indicates is 2 strongest inverse correlation, or if you will to use the example, if start the day with a large pile of money for which I pay you the correlation coefficient between the number of apple you pick and the amount of money in my pile will be -1. What is no linear correlation? No linear correlation means there is no longer relationship between the 2 variables. Example 1, coffee consumption versus intelligence. The amount of coffee that individuals consume and their IQ level has a correlation of 0. In other words, knowing how much coffee an individual drinks doesn't give us an idea of what their IQ level might be. If we created a scatter plot of daily coffee consumption versus IQ level, it would look like this.
There are two types of linear relationship, the positive and negative. Points of variable associations tend to rise upward and to the right. As X values rise, Y values rise as well. Values for Y fall as X values do as well. A mathematical equation that predict response for a specific predictor values is known as a basic linear regression model in the making of prediction. This is used linear regression can be computed using by the equation y is equals to a plus b x, where a is the y-intercept, b is the slope, x is the predictor variable, and y estimate of mean value of the response variable for any value of the predictor variable. Then y-intercept is the predicted value for the response. Y when x is equals to 0, the slope describe the change in y for each the unit exchange in x. The values of a and b can be obtained by using the following.
The theory of geometric thinking. Geometric thinking is concerned with how people reason using the properties of geometric figures in speech and relationship. According to Pearl Vanderbilt, there are 5 levels of thinking or understanding geometry. Level 0, visualization. At this level, student visual perception and non-verbal thinking, they recognize geometric figures by their shape as a whole and compare the figures with their prototypes or everyday things. Example, student recognize rectangle by its form, but a rectangle seems different to them than a square. Level 1, analysis. At this level, students start analyzing and naming the properties of geometric figures. Example, if a student knows that diagonals of a row are perpendicular. Level 2, abstraction. At this level, students perceive relationship between properties and figures. They create meaningful definition. They are able to give simple arguments to justify their reasoning. Example, student at this level may argue that the sum of the measure of the interior angle of a pentagon is 3 times the sum of measures of the angles in a triangle and 4 times the sum of the measures of a triangle with a hexagon. Level 3, deduction. At this level, student can view deductive geometric proof. They are able to differentiate between necessary and sufficient conditions. Example, student established theorem within an axiomatic system. They recognize the difference between undefined term definition, axioms, and theorems. They are capable of constructing original proofs. Level 4, Reichardt. At this level, student understands the way how mathematical systems are established. They are able to use all the types of proof. The example, student understand the relationship between various systems of geometry. They are able to describe the effect or adding or deleting an action in a given geometric system. This student can compare, analyze, and create proof under different geometric systems.
Properties of the levels. The levels have 5 important characteristics. The first one is fixed sequence. A student cannot be at level n without having gone through level n-1. Therefore, the student must go through the levels in order. Second is adjacency. At each level, what was intrinsic in the preceding level becomes extrinsic in the current level. Third is distinction. Each level has its own logistic symbols and its own network of relationships connecting those symbols. The meaning of the linguistic symbol is more than the explicit definition. It includes the experience which the speaker associates with the given symbol. What may be correct at one level is necessarily correct at another level. Fourth is separation. 2 persons at different levels cannot understand each other. For example, the teacher speaks a different language to the student at a lower level. The Van Hellas thought this property was one of the main reasons for failure in geometry. So the last one is attainment. The learning process leading to complete understanding at the next level has 5 phases. First, information. Second is guided orientation. Third, explanation. Fourth, reorientation. 5, integration, which are approximately not strictly sequential.